Hi, welcome to our second community stream for the Bytecode Alliance. My name is Bailey Hayes, and I will be your host today, but we have several other speakers that are going to be joining, giving project updates from, several different places in our community and our stack. Starting with Whammer, then we're going to get an update about JavaScript component tooling, which totally blew my mind for the first time looking at it last week, so I hope you enjoy a demo for that as well. We'll get potentially an update for standards for Wasi, and we'll also go through SIG registry work. So first up is Whammer.
Hello, I am Wenyong Huang, a software engineer from Intel and one of the TSC members of the WebAssembly micro-runtime open source project. Let me give an introduction about the project update of Whammer. The first one is about the fast JIT, multi-tier JIT, and running modes control. The fast JIT is a lightweight JIT engine with quick code startup and relatively good performance. Currently, it supports x86-64 architecture on Linux, Mac OS, and SJAX platforms. The multi-tier JIT was implemented with two-level compilations to tier up from the fast JIT to LVM JIT. The first level fast JIT helps to finish compilation and launch quickly, and then it will be switched to the second level LVM JIT gradually once some function of LVM JIT is compiled, which helps to achieve great performance. The running mode control feature provides APIs to dynamically set the running mode or runtime and Wasm module instance, including the mode of interpreter, fast JIT, LLVM JIT, and multi-tier JIT. And it also enables to run iWasm command line tool with options to set the running mode. The second one is the Wasi thread feature. It is based on the Wasi thread spec proposal, and it implemented the Wasi thread spawn API to create new threads for the Wasm application. Now it can run C application with pthread APIs based on a pthreads enabled Wasi libc. Hello, I am Wenyong Huang, a software.
Sorry about that. I think I cut that one a little bit short. We also have Winyang here who can answer any questions that you might have. I think the main thing to take away is that Whammer has been adding a lot of the new standards that have been coming through, and a lot of the different stuff that we've started experimenting with inside the W3C, where those standards grow, like the Wasi standards. Wasi threads is something that I think a lot of people are really excited to try out and learn and experiment with. So I hope I didn't cut that off. It sounded like it had stopped, but we also have Wen Young here online. So Wen Young, do you mind letting me know if I cut that off or not?
Yes, I I'm online and I can answer questions if there are questions about Wama.
Okay, great. Thank you. What would you say was the most exciting thing that happened in the past month? The number one thing.
The number one thing is the multi-tier JIT support of Wama.
Yeah. Do you mind explaining that a little bit more? So I understand a JIT is a just-in-time compiler, but what does it mean to have a multi-tiered JIT?
Yes, with the multi-tier JIT, it is a two-level JIT tier up. The before that, Wama only has the LVM jet and faster jet individually, but they must run they cannot tear up together. Since the LVM jet's compilation time is relatively long, though it can get a good performance, but the compilation time is a little long, and the faster jet it can get the quickest code startup, and but its performance is not so good as the LVM jet. So we developed the two-level tier-up compilation jet engine, and we firstly we started to compile the Wasm jet functions by faster jet and can get the quick startup, and then we also started the create the backend threads to compile the LNG functions in the backend. And once the LNG function finished the compilation of a Wasm function, the faster jet will be switched into the LNG function gradually, so as to achieve the great performance eventually.
Great. So essentially, hey, JIT is really powerful for getting things to start really fast, right? It's a little bit different from, say, an interpreted mode, which I understand Whammer also supports. But multi-tier JIT means that I can get something started fast, and then I can also improve my performance of my app as it's running, of my Wasm module, after it's already been JITted for the first time. And I think that's really powerful and really exciting. We do have one question from YouTube. I also see that we have Xin Wang here, who is also on the Whammer team. I'm going to bring him in. Hey, Xin, how are you? Did you know I was going to put you online?
Good.
So we have this question. I'm going to drop it in as an overlay, and I'll read it out loud. So Liam Randall is asking if Whammer team has the component model on their roadmap. Xin, do you want to take that one?
Sure. Yeah, we have been watching this feature and the progress closely, and we want to visit this proposal in the middle of this year and give plan for the implementation.
Yeah, so I think there's a lot of different standards that Whammer is pushing on right now that maybe I don't see everywhere, and I think that's really exciting. And it's also really good to hear that the component model is on your roadmap. You know, you're looking for it to sort of stabilize before perhaps implementation. You're paying close attention. So awesome! I think we're all really excited about the component model across the space and across the Bytecode Alliance. I think we've covered most of the main topics for Whammer. I guess one important thing, if you're coming and you're new and you haven't heard of all of these things, there are two main runtimes that are within the Bytecode Alliance GitHub organization. We just did a dive into Whammer. Last session, we talked about what Wasm time is. And so I think it's really great that we support two different types of runtimes, and they do pretty different things. They have very different approaches to a lot of the pieces that are in our space, and it's needed because our space is very diverse. We need to support embedded devices and lots of different business cases. So thank you so much, Xin and Wenyang, for giving us an update.
Thank you, Becky.
Thank you.
Okay, up next, we have Guy Bedford, and Guy is from Fastly, and he's going to show some pretty interesting stuff that he's been working on within JavaScript tooling. Guy, would you like to introduce yourself?
Sure. Thanks, Bailey. So yeah, I just wanted to share some of the stuff we've been working on recently in the component model, and in particular, the way that it interfaces with JavaScript. So for those who don't know, the WebAssembly component model is kind of a new approach to encapsulation of Wasm binaries to try and kind of dig into a lot of these portable code issues at a really deep level and quite a fundamental level. And the JavaScript tooling in particular, kind of has a pretty important place. JavaScript being the original, language and home from which WebAssembly itself grew out of. And so what we're doing is we're experimenting and prototyping a bunch of tooling for JavaScript around the component model. And there's basically two sides to this tooling. You've got the guest side and the host side. On the guest side, it's about taking your JavaScript application, taking some JavaScript and turning it into a component and running it in any environment that supports components. And on the host side, you've got lots of languages and environments that can kind of support running components. And one of the main ones right now is I'm drawing a blank. Wasm time, which is the main runtime, Bytecode Alliance WebAssembly runtime. So in Rust exploring what it would mean to integrate components into JavaScript. So if you imagine a future where we can sort of run components and WebAssembly components in JavaScript together. So those are the two sides of the tooling. And we've got two main projects that I would like to demonstrate for that. Bailey, just to check, you can see my screen okay there? Can you hear me? Oh, we got it.
Yep.
Okay.
Oh, hello, I'm back. Yeah, all right, we've got it pulled
Perfect.
up, and we're looking at componentized JS. I'm gonna go and hide again.
So this is the first project, is componentized JS. And this is the situation of wrapping up a JavaScript application as a WebAssembly component. So it's taking the whole application and the whole JavaScript runtime, in this case, SpiderMonkey, Firefox's JavaScript runtime, and building it into a component. And what I can do is just show you a very quick demo to kind of give an idea of how this works. And the whole workflow is based on taking a JavaScript source file. So in this case, I can have a JavaScript ECMAScript module, which exports a function, returns a string, and then I'm doing a string substitution here based on an import. So this is demonstrating that components have imports and exports. They have these external boundaries where they can bring code in and pass functionality out. So we have two things that go into a componentization process. There's firstly the code that we're componentizing, and then secondly, what's called the widget file or the world. This is what describes the interface and fully describes the entire external interface of the component and what is exported by that component, in this case, a function, a hello function, and what is imported by that component, in this case, a name interface with a name function. And so this looks like normal JavaScript that we would run in a browser or Node.js or something like that. And we've got this new componentized tool that's available on NPM. So you can actually NPM install this, and it's a Bytecode Alliance project, Bytecode Alliance componentized JS. And that gives you this API to basically componentize some JavaScript. So you can import this componentized function from Bytecode Alliance componentized JS. And I'm just going to load that demo, the JS and then the width, and then I'm going to run the componentization function with just that source and the width, those two strings. And it's going to give me a WebAssembly component binary, and that's the WebAssembly bytes. And we're going to save that as demo.component.wasm. So I can run that in Node.js. At the moment, it only supports Node.js, but we could potentially expand that to other environments, and it outputs this demo.component.wasm. And so great, we can take this component now and we can run it in any environment that supports components, Wasm time or others. And because the component spec is defined as this kind of general cross runtime specification, you've got this kind of portable format. But what I can now show you is actually the other tool, which is called Jco. And Jco is a sort of a more generic JavaScript toolchain. And the idea is that it's a kind of a CLI and a bunch of JavaScript functions that can be used to work with components in this experimental phase and kind of explore how they would actually behave in JavaScript. And it's a really nice workflow for prototyping and virtualizing and testing our components. So again, it's available on NPM. And what we're going to use is one of the pieces of functionality here is that it has the ability to transpile components. So it's taking this WebAssembly component and actually turning into something that can run in a JS environment based on the WebAssembly support in JS environments today. So again, if I do a kind of a npm install g Bytecode Alliance, if I spell Alliance correctly, Jco, and I've already got it installed, so I don't need to do that. And then that gives us this Jco command line tool. And I'm going to use the transpile command, and I'm going to transpile that component that we just created. And because of the fact that at the moment, SpiderMonkey has a Wasi dependency, and Wasi as the kind of the main systems virtualization for WebAssembly. We're working on some adapters to be able to virtualize that out, but for now I have to deal with the fact that it's going to output Wasi. So I mean, I can show that so you can kind of just see what happens. If I run the transpilation, it'll create all the files. So there's some core WebAssembly files, and then it's got the main component JS file, which is the JS that represents that semantic component execution. And inside of that file, we've got the imports, and it's got all of these Wasi imports where it's exporting these Wasi virtualization functions, and then it's also importing that name import that we imported. So I'm just going to run the transfer again, but I'm going to do a mapping of the Wasi imports to what we have is another project, which is a kind of a Node.js shim of these Wasi functions, which are kind of the standard random bytes and things like that were being loaded. And then I'm also going to map the name import to, because this is in demo/demo.component.js, I need to backtrack down and load my name.js file. And that should do it, I think. And I've got a name.js implementation here.
Hey, Guy.
Yeah.
Do you mind making your text in your terminal a little bit larger? And also, I realized we introduced a new term that some people might not be familiar with. Can you just explain what SpiderMonkey is and how that relates to this project? Thanks.
Sure. So when I showed this componentization project, this is using a JavaScript engine. So it's a full JavaScript engine. It's the one that's running in Firefox, and that's actually the entire engine that can dynamically run the JS code. And the reason is that because JavaScript's an interpreted language, there's a lot of very, very specific stuff in the JavaScript specification about how the runtime has to behave, which means that it pretty much, I know of no examples of ahead of time compiled JavaScript yet. There's a bunch of research going on in that space. But to fully support JavaScript and the semantics of the dynamic language, you need the entire engine, and it's spec compliance with ECMA 262, which is the specification for JavaScript. So we're actually in the component that we built, it's actually including the whole of Firefox's JavaScript engine inside of that component to be able to run the JavaScript, which I will be able to show you now. So this name function we can just implement it and return a string, which is componentized JS, which is the name of the project, which is that we're demonstrating. And if I want to test this out in Node.js, I can import in JavaScript the hello function from that demo folder and the demo.component.js file. And when I run this JavaScript, it'll import this file and it'll see the imports. And because we mapped them during this transfile step, it should be able to load the Wasi shim in Node.js and that name dependency from this local name file here. And then I can run console.log hello. And if I run that in Node.js, you can see that it's running that entire binary. So one thing to notice is like how fast this thing is for running a whole JavaScript engine and booting it up. And the reason why it's so quick is because we've already initialized the whole JS engine in the WebAssembly binary. So everything is already being pre-initialized, and it's been the engine runtime is already done during build time when we ran the componentized process over here. So the JavaScript WebAssembly that the WebAssembly that you're running in JavaScript is only the WebAssembly to execute this hello function and nothing more, because the engine's already initialized. So there's no setting up of globals in JavaScript. There's a bunch of work to set up all the global objects and things like that go into engine initialization. There is a bunch of directions this demo goes in, but I don't know how much time you want to take up now, Bailey. We can actually get this running in a browser and with errors, and there's a bunch of cool stuff. But if you want to go to questions now, we can also do that.
Let's just say, hey, bring your questions, but I really want to see it in a browser. And so the tool that you mentioned about the way that you kind of pre-initialize the JavaScript runtime within the Wasm component, is that with Wiser?
Yeah, so that's a Bytecode Alliance tool called Wiser, and this is the WebAssembly pre-initializer. And this is a project that will take an existing WebAssembly binary and run it, start executing it, and run through the initial computations and all of those memory changes, and then save the changed memory back into that WebAssembly binary, so that it's just like snapshotting where the execution actually starts. So you can sort of fast forward through all the initialization.
And is that something that Jco uses and just kind of would do it for me?
Right. So internally, when you're using componentized JS, it's going to be underneath. It's actually running Wiser to do this pre-initialization. So this is a really important tool in creating really fast WebAssembly binaries today.
Cool. Thank you for humoring all my questions. I feel like I get to monopolize you, and that's not really fair. But would you like to finish your demo with okay, hey, I've been showing you this in Node.js. So up to this point, right? Let's make sure we follow. We've seen componentized JS, which is a tool that lets us basically componentize and interact and work with components within JavaScript runtimes. But we can also use Jco to make it really easy to take JavaScript code that we write and run that as a WebAssembly component. Is that correct?
It's, I think, the other way around, actually.
Oh,
no! So componentized JS will go from JavaScript to WebAssembly components. And Jco is a bunch of tooling for working with WebAssembly components. And we're thinking of making componentize one of the features of Jco as well as a general tool for working with JavaScript and components. So I think that it can all fall under the Jco project in future, but for now it's still quite experimental. This new componentization, we only just got it kind of in this form recently. But yeah, I can dive into that demo. And so I was using Jco transpile to take this component Wasm and turn it into some JavaScript and WebAssembly that I can run in Node. And that same JavaScript and WebAssembly can actually run in the browser because it's the same specifications and technologies. All we need to do in this case is change the Wasi virtualization there. So I'm going to load our same test that's just doing the console.log. And otherwise, everything else is just the same. But I'm going to rerun the transpilation process. And actually, I don't need to rerun. Sorry, I don't need to rerun the transpilation process. What I'm going to do is I'm going to create an import map that's going to map these Bytecode Alliance Preview 2 shim things into their versions in the browser, which would be in the Node modules folder, Bytecode Alliance. And this is because the browser needs to be told where to resolve things, unlike Node.js, which will automatically look for them in Node modules. So I'm actually going to cheat and copy one that I prepared earlier. So basically the mappings are these, and it's just specifying the file paths to versions of the Preview 2 shim that will run in the browser. And so that's the only path that's different here. And if I run an HTTP server, with some luck, that should work. And you can see we've got hello componentized JS. So this kind of demonstrates the power of like being able to run these components in any environment, where we're actually running a whole JS engine in the browser, and it's incredibly quick to execute that because of the wisering pre-initialization. So yeah, I'll call the demo there, and we can go to questions.
Great, that was awesome.
Sorry,
Hey, we're figuring out this whole streaming thing. This is only our second stream ever, and I keep making mistakes, honestly. So that's on me. And okay, so what you basically showed is a Wasm module that's portable. Both you can run it in Node.js, you could run it maybe even in Wasm time, and you were able to also take. It was basically JavaScript inception, JavaScript runtime inception is really what you just showed us, but with the hello world, right? Because this is all very recent and very new. But the inception being, you've got a Wasm module that has a JavaScript runtime in it that's compiled in, optimized using a tool called Wiser, and then you've loaded that into another JavaScript runtime, which is the browser. That is pretty cool.
Yeah, it's great for demos, and it's really nice for virtualization to be able to really see how this stuff works. But I mean, the interesting thing about the component model is the fact that you can kind of run it in all these different environments, and in a way that's kind of portable and well defined without having to jump through a bunch of binding hoops. So yeah, but in the browser you can really kind of see how it fits together quite nicely, I think.
Is there what are you planning on doing next for this project?
Yeah, so we've got no shortage of work to do. There's a lot of directions we can go in, but I think very much just experimenting with this stuff and seeing what's working and what's not working so well and what we need to improve. At the moment, it would be nice to be able to. We're working on better virtualization for Wasi, so that you could get a version of that without having the Wasi imports at all. That's pretty much the next step on this, and then from there, better support for JS runtimes, because there's a lot of complexity that goes into defining a JS runtime. There's a lot of different features that they include. There's a lot of specs that they include. So it's not just about the JS runtime. There's a lot of web specs that are expected to be supported in these JS environments. So you actually have to implement like a huge amount of code to support a baseline of what users expect to work in a JavaScript environment, and then making that customizable in a way that you can kind of virtualize different environments is going to be a lot of work. But that's kind of the general direction ahead with this work, I think.
And so would you describe the current version? It's experimental. You're trying out different things, but you're asking for feedback. Is that on point mostly?
Yeah, I think it's a nice demo of the component model because you can kind of really get a picture of it. And it's JavaScript's a really easy language to work with. So if you're interested in how the component model works, I think it's a great way to experiment with it, and kind of see how things fit together. It's experimental work. There will still be bugs, but yeah, I encourage people to explore it if they're interested in finding out more about the component model.
Cool. Well, Guy, it was wonderful having you. Thanks for sharing. Yet again, still blew my mind. I've already seen this one, but super excited to see it yet again. So thank you.
Thanks, Bailey.
If you'll stick around, there might be more questions that slide in, and we'll have a Q&A at the end of the stream. Okay, so next on our agenda is to get an update from Dan Goman. Hey Dan, how are you?
Hey Dan, I'm doing good. How are you doing?
I'm doing pretty good. Having fun. And I feel like Guy really set you up for this part because he didn't dive too deep into Wasi, but he was like, hey, we've got these Wasi preview 2 shims. I've got all these different things that I'm wiring together, and it might be really helpful for you to kind of explain what a little bit of that was.
Yeah, and he said a word that's really important. He said the word world. And so it's actually kind of the theme that I'm going to talk a lot about here is the worlds thing. There's a lot of things happening in the last week about worlds. And so I want to talk about some of the stuff that's happening with this concept we have called worlds.
Cool. Take it away.
All right. So I'm going to do a screen share here. All right. So you see my screen now.
Hey, I can. Yes. When I jump off, you won't be able to hear me. So I'm just going to let you run with it so that people don't have to hear my silly antics.
So I got 3 worlds I'm going to show today. The first one is the CLI world. So this one was recently approved by the Wasi subgroup to be a Wasi proposal. And so the CLI world is kind of the preview 2 analog of the preview 1 functionality set. So it has, you can see in this, we have clocks, we have time zones, IO streams, we have file system, random, environment variables, exit. It will also have sockets. Sockets isn't quite in this repository yet, but sockets will also be included in this set. And so one of the things that worlds do is that worlds pull together lots of different interfaces. So Wasi is a modular specification. And so we have all the different interfaces for things like file systems, random numbers, environment variables, clocks for different kind of timings, things. And they're all separate interfaces. And a world pulls these things together into like a single virtual environment. And so this kind of defines, here's the set of things that a component that would be built for this world can do. It can access files, it can access IO streams, it can access the time, it can look at random numbers, and it can use poll to poll for IO events. So this is the CLI world, and so we also have a bit of generated documentation. It's not super fancy yet, but it does kind of show you like the first step of like having all the documentation pulled together in one place. So we have all these interfaces, and these are links you can click on. So I can click on random, and it'll jump me right to the random interface. So we have random data API, and it jumps right into the functions. So get random bytes, and we have get random music4. Again, not the fanciest documentation yet, but this kind of shows you how we can have a single world pull together all the documentation. Oops. Here we go. Pull together all the documentation for all the different interfaces in one place, which is kind of the first step to generating a more complete documentation site from this. So that's the CLI world. The next world I want to show is this world in the Wasi HTTP repository. There is a bunch of exciting things happening around the HTTP proxy world idea. And so HTTP APIs for Wasi is kind of this story that's been going on for quite a while. There's a bunch of different threads of different people working on related things. And so this PR I'm showing in GitHub is actually a place where a lot of different threads are kind of coming together and towards the design of a single world for HTTP proxies that can use the interfaces for HTTP proxy and HTTP APIs. So this is a really exciting thing. A lot of people have been starting to dive into this API, take a look at it, and really start to vet this thing as like the foundation for a bunch of HTTP work. So this kind of shows like we could do worlds for the CLI things, that kind of traditional file system and sockets kind of programs, or we can also do worlds for things like HTTP proxies, where the APIs are more like request and response kind of things, very different kind of APIs. But they both kind of work within the broader Wasi umbrella. We can kind of carve up different subsets of interfaces. We can have command line interfaces. We have proxy interfaces as well. And a third world that I want to show off that's actually seen a bunch of activity recently is this what's currently become called the Bursty world. That name is being discussed. The big idea of the Bursty name is it refers to like serverless or like edge kind of workloads where you think of like traffic being bursty, coming in sort of short bursts. But the bigger picture here is actually it's a really interesting discussion of the kind of world concept and like what should be in a world, like what's the right granularity for worlds. So we have like a single world for all cloud things, or should we like have a different kind of cloud use cases split up in different worlds? There's a lot of interesting discussion happening here. And it really kind of highlights the role of the world is like defining a virtual environment that will be shared between many different producers that want to target a world and many different consumers that will be able to run the world, engine environments and cloud environments that can run the eventual cloud worlds will provide. So that is 3 different worlds that I have seen activity in the last week.
That is awesome. Okay, so three different worlds, and it's like almost impossible when we talk about this not to immediately go into something really cheesy like in a world. But that is the idea, right? Is like imagine a world where you are in a serverless environment, or you're on an embedded device, or you're trying to target a CLI.
Yep.
And so would you say the CLI one is like a little bit further along than the other two? And you kind of showed them in graduating phases of effort?
Yes, definitely. The CLI one is the one that reflects essentially the functionality set that we had in preview 1. So it's file systems. We're adding sockets, which is a pretty big thing, and that's not all there yet. But overall, the CLI one is kind of the most complete and kind of the most defined at this point. For proxies and for this, especially this bursty world thing, I think it's still kind of in the phase of like figuring out what even this concept is. On the bursty side, the proxy one is kind of in the middle, because I think we all have a pretty good intuitive sense of what a proxy wants to do, request and response kind of stuff. But there's still questions about config APIs and like metrics APIs, that kind of stuff we want to add to that.
Yeah, and so you said this, but I want to make sure it's understood, is that the W3C, World Wide Web Consortium, I think is correct, is the group that is working on standardizing all these projects. Wasi is a subgroup of the WebAssembly community group. And all of these worlds are basically now new, and kind of, you can kind of think of them as standardized APIs. In addition to the like more obvious and literal APIs, like the ones that you were showing, that it includes all of the different WID interfaces that are implemented by that given world. Please add more for there.
Yeah, I want to add one thing. So there'll be some standard worlds. We're talking about these standard worlds of Wasi CLI, proxy, and Bursty, if we call it that. But it's also important to emphasize that the plan for worlds is that embedding environments can define their own worlds, and they can define their own worlds that are derived from the standard world. So you could say, I have a world which is like the proxy world plus an additional API that my environment is going to add. So you can use the standard worlds as like a starting point that gives you a baseline that will hopefully have a fair amount of toolchain and ecosystem support for that world. And you could take that and then add your own APIs. If you're in an embedding environment, you could add your own APIs to that, saying like it's a proxy plus my fancy database, or it's a proxy plus my fancy caching system, or whatever I have. I can add on to that. So the worlds kind of serve as a starting point that people can use to customize from there.
So we're basically right now, we've just been talking about a lot of the work that's happening within the W3C. How do you see some of the projects within the Bytecode Alliance use or implement worlds?
So the Wasi CLI world, and when we say CLI, it's also kind of representing like the sort of traditional Unix-ish kind of server process. So we see a lot of people interested in kind of running, fairly traditional servers with the socket APIs, in doing sockets, and then using the pull one off to do async sockets. So people are kind of looking at that. There's a bunch of use cases, and the really great thing about that is that it's really compatible with existing code. A lot of existing code bases are prepared to talk to sockets and do network server stuff over sockets. And so people are looking at migrating existing code bases there. A lot of people are interested in that. On the proxy side, obviously we have a number of serverless vendors and edge computing vendors, and amongst their midst, I work for one of them. And so definitely people are interested in the proxy stuff and using components to do HTTP proxies. There's a lot of value there with the fast startup time and the low overhead. And then I think the serverless thing is kind of like a superset of the proxy world. So the proxy world is kind of like a specialized world, has just like HTTP proxy stuff in it, which would be sort of more specialized for smaller kinds of use cases. The bursty world is actually kind of like the same kind of concept, except that we add more things. We add things like Wasi messaging. We add things like Wasi, the key value store, the pub sub, that kind of stuff. So it's like you're just going to take that idea and we're just going to add more functionality on top of it to have a richer world. So several vendors are looking at that as well. I think it's going to be really interesting to see what people can build with that API.
So the idea is that a lot of people will use one of the runtimes. You know, we talked about Whammer today. Guy mentioned work with Wasm time for component model work. So we could take one of the runtimes that are within the Bytecode Alliance, and there are a lot of different vendors that are interested in all the different ways that you can embed Wasm time into projects. You work for one of those vendors. It's Fastly, and so using something like Wasm time and embedding it, and you would say that you support a certain world. So if somebody sent you a component, you would say, "I compile to this world." Is that a loose analogy?
Yeah, one way I think about worlds is like they're like a nexus. It's like a meeting point between developers and platforms. So developers say, like, I have a program and I'm going to tell my toolchain to target a particular world. That tells my toolchain the APIs that I can use, the features I can use, and that allows my toolchain to, give me good, like an IDE experience where it can show me here's the APIs you can use. I can do autocomplete, all based on the fact that the world is providing these things. And then on the other side of that world, that's kind of like the platform side that says here's the things that the world has to provide, or here's the things that the world's going to do on the execution side. And so those things have to match up. If developers targets a world and the platform implements a world, then the developer's code can run on that platform. And so the world really kind of serves as this meeting point where many different tool chains, different languages, different frameworks, lots of different things will target the same world. And then many different host environments with different Wasm engines, but also different embedding environments wrapped around those Wasm engines can implement the same worlds. And embedding environments, but also including things like different server infrastructure, like totally different ways of implementing worlds. Worlds are entirely virtual, so there's many ways to implement them, especially things like HTTP. I think we're going to see a wide variety of implementations for HTTP, just because there's a wide variety of people want to do with HTTP and stuff in the world. So I think it's going to be a wide variety of things, but really the point of the world is to say there's a single set of virtual functionality, and any application that can target that API in that virtual functionality can run in any environment that implements that world, no matter how it's implemented.
Cool. It's one of those things that feels like we're doing something, kind of entirely new, really pioneering new ways of composing our software together. And this is something that lets us maintain portability, but have the right way of targeting a specific environment. And that can be really powerful. So I really love the new developments. Is there anything else that we should share from the past month? I mean, I feel like there were a million things, but I think progress there is pretty huge.
I think I showed the highlights. I kind of summarized. I mean, behind each of these worlds that I'm showing here, there's been a lot of other details that have to come together to make these things happen. So a lot of it's like, especially standards work, it's not always the most exciting thing day to day, but there's a lot of things going on to make these, progress to the standards process and be ready for the eventual state is we want to standardize these things, or have at least be standards track as soon as possible, so that people can start building on top of them, because that's also very closely connected with stability. People also want stability in these things, so we can build on top of them without having to have all the tools and all the APIs changing. So we're working towards stability, we're working towards standardization. There's just lots of things happening in that space right now.
Yeah, and it's also incredibly exciting. So thank you, Dan, so much for hanging out with us. If anybody has any more questions, we'll have Q&A at the end. And that leads us over next to an update from Kyle Brown on the SIG registry.
Hello everyone, my name is Kyle Brown. I work at SingleStore and I'm here to give an update on Wasm registries. The Bytecode Alliance is a group called SIG registries whose goal is to bring together registry stakeholders and define the use cases and requirements for registry projects. This group is open to everyone and you're welcome to join us. The main project of the registry SIG is WARG. WARG is a protocol that registries can implement to publish and retrieve Wasm packages in a standard way, with strong supply chain security properties. There won't just be one registry like we have with NPM and PyPI, but a federation of registries including general, ecosystem-specific, and private instances. Many of our stakeholders are in the cloud-native computing ecosystem and use OCI, so this means that our registry tooling should be compatible with and leverage OCI registries. So WARG isn't designed to replace OCI, it augments it. If you're using an OCI registry, adding WARG will provide you Wasm-specific functionality and extra supply chain security. Implementation is well underway, and the group has an initial design and prototype with more coming soon. I don't have a demo prepared for today, but you can expect to see some in the near future. Thanks, everyone.
Cool. Thank you, Kyle. So to kind of relate that back, let's say I decided to componentize some of my code, and I compiled my artifact and I had it target maybe a specific world. But when I do the composition and I want something that says it does basically a dependency resolution, I need some way to be able to pull down those dependencies, and I need a way to easily also share my final piece. And so there are a lot of different aspects here. And if you're interested in this project, Kyle mentioned all of these different places, but basically we have the SIG registries repository. We also have the prototype that Kyle was talking about. That's under the registry repo. And if you want to catch Kyle or any of the other people that are working on the project, a lot of the discussion happens over in the WARG channel in Zula. And that mostly completes our content for today. I haven't seen a stream of questions, so I'm going to hang for a second in case people were storing them up, but I'm guessing we might be free. I'm actually, if you guys are okay with it, I'm going to bring everybody back. Hi, everybody. Let's see how many people I can get on screen. And I would like to just say thank you. I know, giving status updates and things, we usually do it in text form, and we share a lot of stuff over GitHub. But sometimes, providing content this way just lets everybody realize that we're kind of all moving in one direction, and there's also just a lot going on. It's really hard to follow any one project. So we're trying to kind of link it all together and give sort of a unified front on all of the updates. So I guess this is a question for my panel here. Do any of you have any questions for anybody else on the panel?
Hi, Betty.
Hey, Shen.
Hi, thank you for the wonderful work for hosting all the events for Bytecode Alliance. And today I want to talk about our plan to create a proposal in Bytecode Alliance for converting TypeScript to WebAssembly. You probably know that we have done some work already, and we think it's mostly feasible, and we'll also get interest from a few other companies. I think it is a good time to create a SIG to have multiple parties working together and see how we can do in that kind of direction.
Yeah, totally. So the process for that, and let me actually, I will share my screen since everybody else has been having to do it. I guess it should be me too. I'm going to drop the Q&A and pull up a tab, maybe, in a moment. Here we go. All right, so I'm over here on the Bytecode Alliance. So basically, we don't have too formal of a process for things, but there are a set of meetings that we already have, and if anybody wants to get involved in any of these, I'll pick on SIG registries, for example. A SIG stands for a special interest group. You try to include something about your meeting here, when you meet, how you do your agendas and notes, and how anyone can get in touch to attend. I'd like to add a little bit more here so that we have a little bit more automation. Right now, it's a person as a service to edit a calendar invite. All of our meetings are open. In the future, I would love it if you didn't have to email me to get added, and I plan to fix that. But yeah, so last stream, Shin, you gave an update that talked about some of the TypeScript work that your team's been working on, and it's really exciting. And you got a lot of interest. I saw Microsoft people jump in, and others have been talking about it. And I agree. I think if you look at it, the top two languages in the world right now are still JavaScript and Python. But TypeScript is right up there because it's so easy to compile that down to JavaScript. But a lot of people would love to be able to write TypeScript, a language that they now love, and have all of the performance benefits that some of the parts that your team was sharing. So yeah, I think there's a little bit of process in the Bytecode Alliance governance for creating new SIGs, but it's pretty straightforward, pretty loose. We're figuring it out, as we go. SIG registry was technically our first one. To do it, I would probably model it loosely off of what SIG registry did, have a charter, all that type of stuff. But yeah, I guess what you're saying is hey, I want people who are interested in this SIG to talk to me, and we'll figure out what we're doing. Is that about what you're saying, Shin?
Yeah. We will check the process and follow it. Thank you.
Cool. Yeah, I'll send you some extra information, and anywhere that's kind of the goal of the Bytecode Alliance is to facilitate all of us working within this space and having a way to build solid software foundations that people are able to build on top of, and having something that enables languages, just like what Guy was showing off, is a really great thing to do.
TypeScript is certainly very important to support. Most developers want to have the benefits of type checking in development. So first-class workflows for that are great. And I'd certainly be very interested to follow more of your research there. It sounds very interesting.
And we also, gosh, was that today or was that yesterday? Talked about interpreted languages. Kyle Brown kind of facilitated an initial meeting around that about, hey, there's a lot of folks that are working on these really dynamic languages between JavaScript and Python and Ruby and PHP, and we're seeing them crop up everywhere. We're seeing lots of people add their own SDKs for all these different things, and there's a lot that we've learned, a lot that we can share. And how do we kind of like converge our efforts on this? And so that's kind of related. TypeScript, I don't feel like you fall in the category, I think, and would definitely fit in here. So let's get this together. I will take that as an action item for me. And yeah, thanks for bringing it up.
Okay, thank you.
Anybody else have any questions? I know it's probably late for a few people. It's about to be 10 o'clock for me, so I'm excited to hang as long as we need. But I think we've gone through most of our content, and we don't have any more questions. So I'm gonna call it. Thank you, everyone. I hope you have a good morning, evening, afternoon, wherever you may be. See you next time.
Thank you.